Bismillahirrahmanirrahim. My name is Muhammad or Munir. Roll number 21 TE05. Our instructor is Dr. Muhammad Jamil. Today I am here to discuss Lab 7 of Digital Signal Processing. That is about a frequency analysis of digital sequence. Now moving toward lab objective of this lab, that is study digital sequences in terms of frequency spectrum, contribution of high frequencies in a sequence, contribution of low frequencies in a sequence. So without wasting any time, let's move toward task 1, that is consider the following sequence. Plot the signal in MATLAB or Octave. If the sampling frequency is 20 kilo samples per second, then redraw the sequence after moving frequencies above 5 kHz. Observe and discuss the effects of this removal of frequency. Second part of this task is redraw the sequence after moving frequencies above 7 kHz. Observe and discuss the effects of this removal of frequency. Now moving toward MATLAB, in which I already written code of this task. That is, first of all, we define a sequence that is given, that is 1 2 minus 1 1 minus 2 0 2 and 3. Then we define sampling frequency, that is 20 kilohertz. Then we define time, that is generate the time vector. Then we give figure, then plot this sequence using plot command, then using x label, that is time, and y label, that is amplitude, that give title, that gives us first figure, that is original signal. Then moving toward the second part, for this we define cutoff frequency, that is 5000. Then we normalize this cutoff frequency using normalized cutoff, that is fc over fc over 2 sampling frequency, as we know that sampling frequency is equal to 2 times of maximum frequency. Then we normalize by using filter signal b, l and x. Then plot this filtered signal using x label, that is time, y label, amplitude, title, that is a signal with frequencies less than 5 kHz. That is main objective of part second of this task. Then moving to our third part of this task, that is given as cutoff frequency, that is 7000. Then normalize this cutoff frequency by using a formula. Then you define a filtered signal, then plot this filtered signal, that using x label, then using y label, then give title, that is signal with frequency less than 7 kilohertz. Now run this code. As a result, as shown, we get three figures. First which, that is about original signal, and second pick, that is frequencies less than 5 kilohertz. ठीक है, and they move toward pick 3, that is frequencies that is less than 7 kilohertz. Now moving toward task 2 of this lab, that is use the following audio sequence that is given by a sir, and demand that calculate DFT, move the upper half of frequencies, which means frequencies above FC over 4, and observe the changes by listening the audio. And then moving toward third part, that is remove the lower half frequencies, which means frequencies below sampling frequency or 4, and observe the changes by listening the audio. Now move toward MATLAB. So first of all, move these pics. Now moving to a task 2, that is our first part. We define an audio read function, and then in path our music dot wave, then using sound command for listening sound, calculate the DFT by using FFT, obtain the frequency axis for plotting using N, define frequency, then plot the magnitude spectrum. For this we use plot command. X label, in X label we use frequency, then define Y label in which we define magnitude, then give title, that is DFT of audio sequence. Now run this task. It will take several time, so wait until we get output. So this is the DFT of audio sequence, as well as sound is also here. Now moving to a task 2, that is part 2, in which we already seen, which demands that remove the upper half of frequencies, which means frequencies above sampling frequency of 4, and observe the changes by listening the audio. So the code is audio read music dot wave, that is our sound. Then find the index corresponding to sampling frequency or 4, which is defined in the task. Then zero out the upper half, then reconstruct the audio sequence using the inverse DFT, then play the modified audio. So run this start. It also takes several time, so wait until we get a output of this task part. So as we listen that in this task we zero out the upper half of DFT coefficients. So moving toward our next part, that is about that remove the lower half of frequencies, frequencies below sampling frequency 4, and observe the changes by listening the audio. So that is our code. We calculate the DFT, calculate the frequency axis by using these commands that zero out the lower half of DFT coefficient, then reconstruct our sequence by using inverse DFT, then play the modified audio. So run this part. It will also take several times, so wait until we get output of this taskbar. So as we as we listen from the audio, we get that we filter out the lower half of the coefficient. So these all charts are from lab number 7. Thank you so much. Allah Hafiz.